going to be going over the Module 1 test review. So, number 1, it says, how can the equation below be written to solve for x? So, we're going to be solving it, even though we just have letters, we're going to be solving it the same way. Alright, we're going to start by getting rid of this negative z. Remember, we do opposite operation to move one thing to the other side of the equal sign. So, the opposite of minus z is plus z. Whatever I do to one side, I must do to the other. Z minus z is 0, gone. I'm left with xy equals, I don't know what p plus z is, so I'm just going to leave it as p plus z. From here, I need to separate. Remember, x is going to stay put, so I need to get rid of y. X and y are attached by multiplication. The opposite operation would be division. And I'm going to divide by what I want to get rid of. In this case, I want to get rid of y. So whatever I do to one side, I must do to the other. I'm left with x. Y divided by y is 1, but 1x and x are the same thing. And I don't know what p plus z over y is, so I'm going to leave it as that. And there's your first answer. All right, number 2, it says, how can the equation below be written to solve for x? So we're going to be doing the same thing, very similar to number 1. The only difference is now we have 2 numbers. So again, we're going to start by drawing our line down the equal sign, put an x in a box. That means we are not touching x. Let's start by getting rid of that 3y. I don't want to separate 3 and y, so I'm going to leave them together, and I'm going to do opposite operation. I'm going to minus 3y. Whatever I do to one side, I must do to the other. 3y minus 3y is 0. I don't know what p minus 3y is. They're not like terms, so I can't combine them, so I'm going to leave it as p minus 3y. Equals 3x. Now, I want to get rid of the 3, because remember, x needs to stay put. 3 and x are attached by multiplication, opposite operation, division. I'm going to divide by what I want to get rid of. Whatever I do to one side, I must do to the other. 3 divided by 3 is 1, but 1x and x are the exact same thing. And in this case, I can do a different step. So it's going to be a little bit different than the last one here in the last step. So p divided by 3, don't know what that is, so I'm going to leave it as p divided by 3. Now, I do know what negative 3 divided by 3 is. I know negative 3 divided by 3 is negative 1, and I bring down my y. Now, negative 1y and just negative y are the same exact thing, so we can actually get rid of that one. And there is our final answer. All right, number 3. So in this case, we're solving for x1. So again, we're going to put x1 in a box, and we're not going to move it. We're going to draw our line down our equal sign. Our first step is to get rid of this fraction. So if I want to get rid of this fraction, I know a fraction is division. Opposite of division is multiplication. Now I know this fraction is multiplying by everything here. That 1 over 3 is multiplying by parentheses, and the parentheses multiplying by h. So if I want to get rid of the fraction, I'm just going to do opposite operation. So if I times by 3, I get rid of the fraction. Whatever I do to one side, I must do to the other. Your 3's are going to cancel out. 3 times a equals 3a. And then I'm going to write down whatever I have left. All right, now 1 times anything is itself, so I can actually get rid of that 1. All right, from here, I want to get rid of this h. So I know the parentheses and the h are multiplying. If I want to get rid of the h, I can do opposite operation and divide both sides by h. H divided by h is 1, but 1 times anything is itself. So all I have left now are x1 minus x2 equals 3a over h. And then my final step, I want to get rid of this negative x2, so I'm going to add x2 to both sides. x2 minus x2 is gone. I'm left with x1 equals, I don't know what 3 over h plus x2 is, so I'm going to leave it as 3a over h plus x2. And there's our answer. Okay, for number 4, it says a financial analyst at a small video game company develops the expression 4.29g minus 5,671 to estimate the amount of profit per game sold, G, for a version upgrade of one of its games. The company sets a goal of $123,029 profit on the game for the first month of its rollout. How many games does the company need to sell in order to reach its profit goal? So they started by giving us the equation 4.29g minus 5,671 equals our profit per game sold. So if they already tell us their goal profit, I can actually substitute the profit for the amount of profit that they are looking for. From here, we can go ahead and solve like any other problem. I want to start by getting rid of, remember, G is what we're solving for. We want to figure out how many games they have to sell in order to reach their goal. So I'm going to start by adding the 5,671 to both sides. Move that over first. We're going to have 4.29g. And then these are going to cancel out. And we're going to go ahead and add these two numbers. which is going to get us 128,700. And then from here, we're going to go ahead and get rid of the 4.29 using division. Whatever we do to one side, we want to make sure we do to the other. 4.29 divided by 4.21 is 1, but 1g and g are the same exact thing. And when I divide by 4.29 on the other side, I get 30,000. So that means the gaming company needs to sell 30,000 games to reach their profit goal. All right, number 5. An Uber ride in Orlando costs $2.50 plus $7 for each mile traveled. Write an equation to represent this situation where D is the distance traveled. If Brandon traveled 9.5 miles by Uber, how much was the cost C of his Uber? Which equation represents the situation and the cost of Brandon's Uber ride? So we're going to start by building our equation first. We know that our Uber is going to cost us $2.50 no matter how far we travel. So let's start with our $2.50. Now, plus, we know we're going to be adding, and we're going to be adding $7 per mile. I don't know how many miles we're going to travel, so that's going to be where my variable comes in, M. So I'm going to do 7 times M, because depending on how many miles we travel per each 7, we're going to multiply, equals our cost. So that is going to be our equation. Now let's look at, they tell us that Brandon wants to travel 7.5 miles. So instead of M, we now know what we want to plug in. We want to plug in 9.5. So now we're just going to either type it into our calculators, or you can follow PEMDAS to solve it. So we can start by doing 7 times 9.5, which is going to get us 66.5. And then we add our 250, which is going to get us $69. So that means Brandon's Uber is going to cost him $69. Number 6 says, Dan borrows $230 from his brother to buy a lawnmower. He will repay $65 to start and then another $15 per week. The equation can be used to determine W, the number of weeks it will take for Dan to repay the entire amount is, and they give us the equation. Now we're filling in for A and we're filling in for B. How many weeks will it take Dan to repay the entire amount? And C. All right, so let's start with building our equation. Let's start with what we know. Well, we know that Dan borrowed a total of $230 from his brother, and he's working to repay. So we know that he needs to repay $230. That's how much money Dan has to repay in total. He's going to start with 65, and he's going to continue to pay $15 per week. We don't know how many weeks. So now let's see, what could we plug in for A and B to make the situation true? Well, we have our 250. So that's good. We have 65. So we're multiplying 65 times something should give us our 65 because we know that's how much he's starting with. And I know the only number that I can multiply for this to say 65 is 1. Then I'm looking at 15 times my W times our weeks to get us our total paid. And now we can go ahead and solve. So we're going to start by subtracting 65. Whatever I do to one side, I must do to the other. 65 minus 65 is 0. I'm left with 15W equals 230 divided by, or minus 65, which is going to get us 165. And then we're going to go ahead and divide both sides by 15. And it is going to take Dan 11 weeks to pay back his brother. And that's what we're going to fill in for C. All right, number 7. So number 7 says we're solving for an absolute value equation. So the first thing we want to look at is make sure that our original equation is set equal to a positive number, which in this case it is. So there's already an answer choice that we can eliminate, letter E, because E only works if it equals to a negative. So now let's start by building our second equation. So now that we've built our second equation, we want to go ahead and start by solving the first one. So we always start by drawing our line down the equal sign. Now we're going to start by getting rid of that negative 4. We're going to be doing opposite operation. So I'm going to add 4 to both sides. 4 minus 4, gone. I'm left with negative 4x equals 28 plus 4, 32. From here, I'm going to get rid of this negative 4 by dividing both sides by negative 4. Negative 4 divided by negative 4 is 1, but 1x is the same as just x. 32 divided by negative 4 is negative 8. So there is our first answer. Right, now we move on to the second side. Again, start by drawing your line down the equal side, and you're going to follow pretty much the same steps. We're going to start by adding 4. Now, the only difference to this problem is this 28 is now negative. So I'm going to do negative 28 plus 4, which is going to give me negative 26. I'm going to divide both sides by negative 4. I get x equals positive 6. And there is our second answer. Now, let's say you forgot how to do all of this. You could always go back and plug in the possible answer choices, especially if it's multiple choice. Now, I could check my work by plugging in. And you would plug in for x. If you get a true statement, that means your answer is correct. All right, number 8. It says a store is having a contest where customers guess the number of pieces of candy in a jar. If a customer guesses a number that is within 4 pieces of the actual value of 362 pieces of candy, the customer wins a $25 gift card. For which absolute value equation does the solution set of the equation give the smallest and largest guess a customer could make and still receive the gift card? All right. So let's start by, we know it's an absolute value equation. So we know we're going to have our absolute value bars. And in this case, they can be within 4 pieces of candy. So they can either be up by 4 or they can be down by 4. This is when our absolute value is important because we know that in an absolute value, we get 2 answers. We get one that's positive and we get the second one that we turn to a negative. So we know it has to equal 4 because that's the only way we can get a positive and a negative answer. You can't have negative 362 pieces. So we're going to start by eliminating B and D. All right, from here, we're going to look at what are the possible number of candies that she can have. Well, we know there's 362 in the jar. We know we can take 4 away. They can be 4 less. That would give us 358. Or they can be over by 4. 366. So these are the 2 options. So let's take a look at A and B. If I plug in, for X, if I plug in 366, let's assume they guess 366 in both cases. If I do 366 plus 362, do I get 4? I do not. If I do 366 minus 362, I would get 4. So that is how I know my answer is C. Because if I also try doing 358 minus 362, I would get negative 4, and that also works in this problem. So we know our answer is C. All right, and our final problem, number 9. It says a poll indicates an approval rating of 47.5% for a city mayor. The poll has a margin of error of plus or minus 3.5 of percentage points. For which absolute value equation does the solution to the equation give the possible minimum and maximum approval ratings for the mayor? All right, so because we know our plus or minus is 3.5, I know both my equations should equal positive 3.5 in the absolute value and equal negative 3.5. So I already know I can eliminate A and B. All right, so now we're going to take our 47.5%, and we know we can be less by 3 or more by 3. So we're going to take 47.5, and we're going to subtract 3.5, which is going to get us 44. And we are also going to add 3.5, which is going to get us 51. So these are the 2 possible percentages. So let's go ahead and plug them in and see which one gives us a true statement. So if I plug in 44 for C and D, if I do 44 plus 57.5, I do not get 3.5. But if I do 44 minus 57.5, I get 3.5. I get negative 3.5, which actually works if I plugged in 51 minus 57. Oh, minus 47. Sorry, there should be 47 and 47. If I do 44 minus 47.5, I get negative 3.5. And if I plug in 51 minus 47.5, I get positive 3.5. So those will both work. And that is going to be our final question for Module 1.